Welcome along to a tutorial. This one's designed to show you how to plot lines of best fit, and once we've plotted that, we're also going to develop an equation to describe that line. So firstly, get yourself a ruler, preferably a clear plastic one. What we're going to do is we'll count the number of points, and you can see here we've got 8 data points, and I'm going to put a line of best fit which cuts those 8 data points so that half of those points, 4 of those points are below the line and the other 4 are above it. I'll extend my line all the way through to the y-axis. Okay, so you'll see here I've got my line of best fit, and I've made it so that there's 4 points above it and 4 points below it, nice and even, and preferably with the space between the combined space of the points above the line equal to the combined space of the points below the line. Okay, so we've got that. Having determined our line of best fit, which is what this is, we can now determine an equation for it. So in general, our equations for line of best fit can be written as y equals mx plus c, where m is the gradient or the slope of the line and c equals the y-intercept. You might remember this from year 9 and 8 maths. I certainly hope you do. So we'll start initially by actually looking at how to get the y-intercept, and that's perhaps the easiest of them. The y-intercept is simply a point on the graph. So what you do is you actually look at the graph and you mark where the line that you've just drawn has cut the y-axis, and so you can see why it's important to extend your line of best fit right through to that point. You actually see that your line of best fit, this value of c, which I'll call the y-intercept, equals, in this case, about 475. So you make a note of that. Now, having got that, we'll then choose 2 points on the graph, and we're going to look at points which basically will allow us to easily calculate m, the gradient of the graph. It can be any 2 points, but it must fall on the graph. So I'm going to choose this one, which intersects one of those grid squares really nicely. And I'll come to another point on the graph where hopefully it'll do something similar. This one's not too far off here, so I'll mark that one in. These 2 points could be anywhere as long as they sit on the line. I'll now form myself a little triangle. And from that triangle, I'm going to determine the rise and the run. So obviously this is the rise. And the rise is this particular point here, which has a value of 550, minus this particular point here, which has a value of 500. So our rise in this case is going to be a rise of 50 as we move from this point up to this point. We then now turn our attention to the run. I'll try that again. Now the run is how far acrossways we actually move. So we've started at this, well, we've got to this point here, which is at the point about 2008.5. That's a funny sort of figure, isn't it? But 2008.5. And it started here at this point, which is about 2007.5. So our run there is just 1. Okay, so how does that help us? We'll come back over to this side here and we'll actually do some calculations. Now our gradient of that particular line, which we're calling m, equals the rise over the run. Now we've already determined that our rise is 50 and our run is 1, so our gradient has a gradient of 50 divided by 1, which is just 50. Okay, so now, having done those calculations, we can go back to actually what we're working through up here, which is determining what equation we've got. Now we've just calculated the value for m, which was 50, and we keep x in there. And we also determined by looking at the graph that the y-intercept c has a value of 475. So our equation is y equals 50x plus 475. What does this mean in reality? Well, on our y-axis, we've got the number of students. On our y-axis, And the number of students will equal 50 times the year in which those students were there. So first year, second year, third year, fourth year, etc. Plus a value of 475. So what this then helps us do is predict what might happen as the years go by. And quite clearly you can see there is an increase as the years go by and we get more students at Chisholm. What we can do now with this equation that we've got here is actually go through and calculate exact values or predicted values for that. Remember, whenever you use these equations, they are predictive equations. They don't tell you necessarily exactly what you're going to get, but they will give you an indication about what we can expect. And that's one of the strengths of this type of modelling. Thanks for that.